Okay, today we are going to discuss the chapter 1 of our relations and the functions. Uh, we're going to just revisions those topics. Let's see here asking the questions. Determine whether each of the following relations are reflexive, symmetric and transitive. I'm going to do 50% of maths from here, so I'm not going to do all the maths because it will take a lot of time, but I'm just going to the similar maths. I'm not going to discuss 1-2 maths. I will be discussed. Okay, and let's see here. The first one has asking that relations are in the set A, where 1 to 14 define as r is equal to x, y, 3x minus y. This is the relations, and the set has given here A. So from here, let us assume that A is equal to 1 to up to 14, and the relation is x, y, 3x minus y equal to 0. So here given the conditions 3x minus y equal to 0, so 3x equal to y. So here for y equal to 3x. Now value put kora x or jagat ami hardly value keta yaleke anibo parim 14 leke ahibo lagibo order pair, and after this we cannot take others. We cannot take the value which is more than 14. Let's see here, in place of x or jagat 1 put kore and y value 2 put kore 6, 3 kore 9, 4 kore 12. Let's see, for reflexives we know that the elements should be equal, or in ordered pair the first element and second element should be equal. So here 1 1 2 2, like that kind of element, that kind of ordered pair we hadn't get in the relations, and that's why it doesn't belong to R. For symmetricity we know that if 1 3 belonging to R, then the reverse condition should be satisfied on the relation. So 3 1 doesn't belonging to R. Suppose that one is A, that one is B, then B should be in the first position, A should be in the second position. That doesn't belong to R. Okay, so 1 3 is belongs to R, but 3 1 doesn't belonging to R. So that's why it's not symmetric. And for transitivity, you guys know that 1 3 belong to R, 2 6, so 1 6 should be belong to R, but it doesn't belonging to R. R means in the relations. So 1 6, so only 4 ordered pair we have got from here, but we haven't got 1 6. That's why it cannot be transitivity. Okay, another one given here, relation R in set N and denotes natural numbers are defined as R is equal to x, y, y, x plus y, and the condition has given the element of x which is less than 4. So from here we can find out the ordered pair. So we can take the x value up to 3 because the conditions has given x is less than 4. So if we are going to take 1, then 1 plus 5, y value is 6, 2, y value is 7, 3, y value is 8. Okay, so as I mentioned in the previous classes, the reflexive means elements should be equal, but it cannot be equal, you see. So x means 1 1 2 2 3 3. We haven't had get like that kind of element in the relation, so it doesn't belong to us, so it cannot be reflexive. And for symmetricity we know that x y belong to R. So the reverse, that means yx should be belong to R, but you see here 1 6 belongs to R. In the first position we have to take the 6, and second position 1. It doesn't belonging to R, so it cannot be symmetricity. And for transitivity, know that xy belong to R, yz belong to R, but xz should be belong to R. From the given relations, 1 6 is belongs to R. See here, 1 6 belongs to R, 2 7 belong to R, but 1 7 doesn't belonging to R. So R cannot be transitivity. Okay, for the next one we are going to discuss like that kind of match, only one now. Relations are in the set Z of all integers. So now we are going to take the integers numbers